a spectrum of design complexity. We're ZYCAD. Concurrent engineering is our specialty. We're ZYCAD.
Good afternoon, ZYCAD Corporation. No, I'm sorry, they're all busy partying this afternoon. You'll have to call back. Thank you.
At the same time, we were working on design, and by the 12th of December, we've already released our first cards. We had set an internal goal to have the power on the machine by the 1st of January, and we didn't quite make that, but that was clearly the direction. We had a simulation model by the 1st of the year. Again, we're only 6 months into the project at that point. We focused on releasing the pipe card and first jobs. Power Up actually came 26th of January. Again, that's about 7 months into the project, but we were actually able to run maintenance tests and loop-back tests between the simulation module and the in module. Over a week later, we released the path trace card. The memory engine came along a month later, but we had strategically pushed that one out since it was we thought the least risky part of the architecture, making the fewest architectural changes. But again, within a month of the time we powered the first cards on, we actually had the first job running successfully.
You can see the pin 1, pin 2, where there's pin 3, pin 1 through 3 down here. Basically, there's some differences between the LE and the SD, or the LE and the walleye too. We handle things much differently here in the pin 1, pin 2, pin 3 arena.
Research we've done benchmarks and so forth, seems that there's little actual scheduling for each sample. So we figured that one team could handle it, and it looks like it's doing a pretty good job.
The basic feature is packet 2, you simply flag the gates you want to have spike delay with a notation that this is a spike delay. It receives an input which could cause a hazard condition. In other words, the spike width is less than the rise fall.
The SVD's memory modeling was still low. We were a little concerned with going to 4 memory gates in the packet 14, trying to load all that data. It would just take too long. So the main thrust of the design is trying to speed up the loading.
If you look through the evolution of the LEFD to the SD to the 4, actually, on the LE there was a concept of stuck, and we altered the normal processing of altered the processing of normal events by stuck, but after you stuck it, you were pretty much stuck.
So this simple example just shows a very simple clock with a period of 100. The clock tag itself was modeled after the Xylos dot CLK, is operator for defining clocks in Xylos.
There's 4 types of changes. Change fan outs by adding them. You can add or replace a gate, delete a gate, keys never shown. Or you can change the parameters, change the delay or the type. Like Steve said, it's a microcode feature. It should come in handy in a really big network.
To load up bus codes into a RAM, just as if they were coming from the M module. One of the requirements was we still had to run test initialization that would load from the M module, so this connection had to be intact. But we could also write those bus codes and bus commands into an S writer. And the pipe cards, the GD keyboard, and the MMA cards, but all 16 are cycling at the same time. When they're done, it sends status back to the M module, and the M module make sure that it was good.
Probably because we just didn't want to stand there for 2 hours, and some really basic problems would go unnoticed until they, wound up being differences in the simulation. We end up spending days and a lot of time at it. So now we have something that I don't think is unreasonable at all to ask, the customer to go punch the button and let it rip through it on a daily basis.
The manual was basically a new manual. We started with the LEFD manual, which was already a new manual, which we did earlier on, and added the additional features to it, described new things, and tried to make it more complete.
Junior Fry.
Running up. The number of cycles busy count, the number of empty sample times. The empty sample times is what was added for the 4X. What you could do with it,
Basically, when overflow occurred, we'd set an overflow bit in the DI card, which would then track module global air, period. That's basically the extent of the air tracking buffer on the SDE. So it's not a big deal.
flash. 2 or 3.
Well, you always when you see my slides, I'm a busy executive. We don't have time to set everyone on their excellent slides. Back in time. Basically, if you had an input change into a node where it went to a 1 but didn't last for even a full sample time, it was just a spike. And then everything turns off. The node will actually end up coming from a 0 and going to a 1. A floating 1. Take a minute to schedule it for.
He just snuck out.
I thought that we might take this opportunity.
I got his wallet, let's do it.
Wednesday might be a good day. Can we do lunch?
Yes, Steve.
You here Wednesday, Steve?
Sure.
Good.
Go to compile that design, if you substitute one line, you can get a different macro, one that includes setup and hold. And I chose the 374 as an example. It's one that doesn't have a whole lot of timing checks with it, but it has eight sections. So there's 168 sections of 374s on the board. Typical run is 200,000 sample times, so that's about 2,000 clocks. That gives you 336,000 potential timing violation.
We never had any parity checking. We have partial design in there. We have pushed the state in there, but never worked. The other thing we had was an overflow bit that checked some of the internal stats. So we changed it to 4X. We changed it to parity checking in. We have checking is wherever these little stars are. So we check between, we go from M to G or G to G modules. We have parity checking on all major buses. And internal, we also have checking from as the data comes in, and on the major internal bus.
On everything that needed improvement. So the casters are the same as what are on most of the other cabinets, and just about everything else is new.
We see those.
Can you crawl?
Yeah, we should.
Yeah.
Good job.
Some of the problems that we had seen in the past with ground shift, crosstalk, electrical noise, and things like that in SDE and elsewhere were kind of the major issues that we wanted to resolve on this machine. So I'm going to kind of start from the inside and work out. Started out with a board size that's just about twice the size of the boards we've been used to around here. They're 12 by 19, significant in a lot of places. The length from a module to an S-Quest board, for example, in the SDE was about 36 inches or so, and on this system it's about 3 inches. So, we only have one power supply in here, but the power supply is here, right behind the module, and the rest of the power supplies plug into the power strip here with a power box in the bottom of the cabinet. So you have a cable modeling job,
Ray. Gilson.
Put it in the right place.
You ready? Contact?
It's going to show there, right?
It's the late show.
All right, I'm ready.
Loading.
Look at the lights.
Doesn't get
This was module 1. It's a bus interface card. You look over there, it tells you that it's telling you missing information.
Read it out, Ray.
It says first physical, first error in physical module 1 is a bus interface error. The first error detected by physical module 3 is a global error, which means this guy picked up a global, but it wasn't caused by it. And the red light's verified.
You're talking about DSC.
The red light's verified the software.
Not to simulate mode. Give John Hanson some lights he can turn on and off, and
Seal error that prevents it from running, but there's an error here in the M module itself, in the M module processor, or if it can't communicate with any of the modules, then you power it up.
Okay, so that's why the parity error that is caused is in a module.
Just up, right?
Chamber cell.
I don't think so, right?
It's a tremendous benefit, and it's unfortunately all too unusual. So I really applaud all of you for the effort and the accomplishment that you've been able to do here. Before I say any more, I wanted to read a letter from Mark Parson, and he is going to be here, I guess, a week from Tuesday. He had wanted to be here today, but was unable to. But he did send a letter, so next Tuesday he'll thank you all personally, but let me read his comments. To the System Evaluator team, my congratulations to each of you for outstanding performance. Achieving your goal 6 weeks ahead of schedule on such requirements that are beyond the specific goals will help us all get the product. Will help us as we get the product ready for shipment. We should have gotten the big version.
You should have read it on the plane, I think.
I believe your success has been due to the talent and experience within the team, as well as the way you approach the task. Be tight, you can continue to help during this next phase. Again, my strongest congratulations and best wishes for continued success in your careers, whether with ZYCAD or outside. I look forward to thanking each of you personally when I'm next in St. Paul, which will be the afternoon of Tuesday, May 30th. Here's the letter. I wanted to reinforce a couple of the points made there, namely that we are enthusiastic about being able to show it at DAC. I guess for the last couple of months we've been planning on showing the skins, but now to be able to actually show the working module with the lights is going to make a big difference. It's actually going to be situated in the middle of our booth area up on a small pedestal, and there are going to be a couple spotlights on it. So it actually will be one of the main new product, one of the main things, highlights of the ZYCAD booth at DAC this year. In addition to the physical hardware, we're also using the design story of the walleye in several of our demos, where we're talking, because in fact, having used our own tools and having successfully seeing the success we've had with that.
You come on the project. So let me at least say congratulations. I think it was a really tough time you've had. It looks easy now if you look back on it, that all you've done is got this thing working, and it's working so smoothly you can't imagine the difficulties that you went through trying to develop it. I know Steve has had some hard times keeping this thing together. I know you've all contributed with very long hours and very smart work, and I'm really pleased to see what's happened, and really pleased for yourselves and for the company that we got such a successful product. So having said that, I'd like to sort of issue these checks out, which might be of interest to some of you. So what I'd like to do is, just in no particular order, certainly not even alphabetical, like to offer you our enormous congratulations from the company, from everybody in the company, and pass out these checks right now. The first name is Steve Hansen. Congratulations, Steve.
Thanks very much. Next guy is Dick Avison. One of those rugged after pulp Peters in the south.
The same race.
My younger brother is looking for jobs in
You want to see the... Hi, Mom.
I'm going to Disneyland.
I'm going to Disneyland. Anyway,
Whatever it was. I'm sure you will. I'm sure you will. Everybody has one.
those are lubricated for life.
They're also 50,000 mile covered by the dealer, so I guess they have that replaced anyway.
Everybody gets similar.
And he's the one that was scared to death. I mean, he's walking around here.
Does that have sound too?
seriously
Yeah.
thinking like there wasn't enough.
We're taking a big shit on this white car over here.
Let's go by, gotta go by, don't bum me. That's what happened to Nick Stevenson. I mean, he held it right until the last second, then he just whang. Bart said he wanted to pick the shot. Whoa, did you see that? What is that?
That's a turkey, the best.
Looks like you're wielding all your Colts today.
Not all, just some.
There you go.
Pretty poor.
Christers was documenting this whole event. The old ZYCAD, the way it used to be.
No, that was no cameras.
Oh. Is it fun, Steve?
Oh, it's fun, Krister. You're supposed to turn up the audio gain so you can hear the wheel against the coat hanger.
Good evening, ladies and gentlemen. Our next category is a new one this year, winning in the wake of a quake. The winners are, Quake, the ZYCADettes, the best in the West.
It's a big one, guys. It's a big one. It's a big one.
This is the big one.
To win, you just got to keep your eye on the ball, man. Just keep your eye on the ball.
Oh my, Minnesota was never like this.
Managing the spectrum of design complexity, where ZYCAD. Concurrent engineering is our specialty, where ZYCAD. VHDL and the Mach and the system evaluator. They make us the top. We're ZYCAD. There is no design that's too complex for us. We simulate, integrate, much better than ICOS. We're ZYCAD. Simulation hardware that makes it all go. Simulation software that's running the show. We're ZYCAD. It's our VHDL that makes us feel so fine. It's got speed and fancy stuff. The competition's grind. We're ZYCAD. From architectural level to switches and gate, our products are the best, our support's first rate. We're ZYCAD. ZYCAD. Managing the spectrum of design complexity. We're ZYCAD. Concurrent engineering is our specialty. We're ZYCAD. 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 And we're gonna win again and again. And we're gonna win. And we're gonna win.